Good morning to all of you. My name is Dhananjay Rajak and I am Assistant Professor, Department of Mining Engineering, Maths University, Raipur. So today our topic is Theodolite surveying. So far we have been measuring horizontal angles by using a compass with respect to a meridian, which is less accurate, and also it is not possible to measure vertical angles with compass. So when the objects are at a considerable distance or situated at a considerable elevation or depression, it becomes necessary to measure horizontal and vertical angles more precisely. So these measurements are taken by an instrument known as theodolite. So what is theodolite surveying? The system of surveying in which the angles are measured with the help of a theodolite is known as theodolite surveying. The theodolite is a most accurate surveying instrument mainly used for measuring horizontal and vertical angles, locating points on a line, plotting, prolonging survey lines, finding difference of level, setting out curve, ranging curve, and tachymetry survey. Let's know about transit vernier theodolite, which is a type of theodolite. In this pic, you can see the cross-sectional view of a transit theodolite. In this line of sight is the vertical axis, and this line of sight is a horizontal axis. In this is the telescope, and this is the altitude bubble, this is the objective vane, and this is the eye vane. This is the trived, this is the tripod head, and this is the tripod leg. This is the leveling screw which is used for level the theodolite, and these all parts are leveling head. And this is the cross sectional view of a transit vernier theodolite. This is the upper plate, this is the vernier, this is the vertical axis, this is the upper clamp, and this is the lower plate. In this page, you can see the graphical view of the transit vernier theodolite. This is the vertical axis and this is the horizontal axis. This is the vertical angle or vertical circle by which we can measure the vertical angle, and this is the horizontal circle or horizontal angle by which we can measure the horizontal angle, and this is the telescope used to sight the object. This is the objective side and this is the eyepiece side. This side is in the observer and this side is in the objective or object. This is the circle which is horizontal or vertical. Now, classification of the theodolite. Theodolite may be classified as a transit theodolite and non-transit theodolite, and by the manufacturing vernier theodolite and micrometer theodolite. Classification of the theodolite. Transit theodolite. The theodolite is called transit theodolite when its telescope can be transited. There is revolves for a complete revolution about its horizontal axis in the vertical plane, whereas a non-transit theodolite is in telescope cannot be transited. They are inferior in unity and have now become absolute. Classification of the theodolite. Vernier theodolite. For reading the graduated circle, if verniers are used, the theodolite is called as a vernier theodolite, whereas in a micrometer, theodolite is provided to read the graduated circle. The same is called as the micrometer theodolite. Now, size of the theodolite. The theodolite is designed by the diameter of the graduated circle on the lower plate. The common sizes are 8 cm to 12 cm and 14 cm to 25 cm. Now terms used in manipulating a transit vernier theodolite. Centering. Centering means setting the theodolite exactly over an instrument station so that its vertical axis lies immediately above the station mark. It can be done by means of plumb bob suspended from a small hook attached to the vertical axis of the theodolite. Second is transisting. Transisting is also known as plunging or reversing. It is the process of turning the telescope about its horizontal axis of 180 degrees in the vertical plane, thus bringing it upside down and making it point exactly in opposite direction. Third is swinging the telescope. It means turning the telescope about its vertical axis in the horizontal plane. A swing is called right or left according as the telescope is rotated clockwise or anti-clockwise. Fourth one is face left or face left observation. If the vertical circle of the instrument is on the left side of the observer while taking a reading, the position is called as the face left or face left observation. Now, fifth one is face right. If the vertical circle of the instrument is on the right side of the observer while taking a reading, the position is called as the face right, and the observation taken on the horizontal or vertical circle in this position is known as face right observation. Changing phase. It is the operation of bringing the vertical circle to the right of the observer if originally it is to the left and vice versa. It is done in two steps. First, revolve the telescope through 180 degree in a vertical plane and then rotate it through 180 degrees. In the horizontal plane, there is first transit the telescope and then swing it through 180 degrees. Seventh one is line of collimation. What is line of collimation? It is also known as the line of sight. It is an imaginary line joining the intersection of the crosshairs of the diaphragm to the optical center of the object glass and its continuation. Axis of the telescope. It is also known as imaginary line joining the optical center of the object glass to the center of the eyepiece. Axis of the level tube. It is also called as the bubble line. It is a straight line tangential to the longitudinal curve of the level tube at the center of the tube. It is horizontal when the bubble is in the center. Tenth one is vertical axis. It is the axis about which the telescope can be rotated in the horizontal plane. 11th one is horizontal axis. It is the axis about which the telescope can be rotated in the vertical plane. It is also called as the Trunnion axis. I think it's last one. Now, adjustment of a theodolite. There are two types of adjustment in the theodolite. First is permanent adjustment, which is adjusted in the time of the manufacturing of the theodolite, and second one is temporary adjustment. Let's know about permanent adjustment. The permanent adjustments are made to establish the relationship between the fulfillment line, fundamental lines of the theodolite, and once made, they last for a long time. They are essential for the accuracy of the observations. The permanent adjustment in case of a transit theodolite are adjustment of the horizontal plate levels, collimation adjustment, horizontal axis adjustment, adjustment of telescope level or the altitude level and plate level, vertical circle index adjustment. And the second one is temporary adjustment. Temporary adjustment is used in the time of the observation in the field or in the time of the surveying in the instrument station. The temporary adjustments are made at each setup of the instrument before we start taking observations with the instrument. There are three temporary adjustments of a theodolite. First one is centering, second one is leveling, and fourth one is focusing. Third one is focusing. Now, measurement of the horizontal angle. There are three types of measurement: ordinary method, repetition method, and reiteration method. We know about the ordinary and repetition method. Ordinary method. First, the process of the ordinary method to measure the horizontal angles are: first one is set up the theodolite at station O and level it accurately. Set the vernier A to the 0 or 360 degree of the horizontal circle. Tight the upper clamp. Then loose the lower clamp. Turn the instrument and direct the telescope towards A to bisect it accurately. With use of the tangential screw, after bisecting accurately, check the reading which must read 0. Read the vernier B and record both the readings. Fourth, loose the upper clamp and turn the telescope clockwise until line of sight. Bisect point B on the right hand side, then tight the upper clamp and bisect it accurately. Read the both verniers. The reading of the vernier which was initially set at 0 gives the value of the angle AOB directly and that of the other vernier P by deducting 180 degree. These are all the methods of ordinary method to measurement the horizontal angles. This is the repetition method. Time is late. Now measurement of the vertical angles. Vertical angle. A vertical angle is an angle between the inclined line of sight and the horizontal. It may be an angle of elevation or depression according as the object is above or below the horizontal plane. In this case, the line OA is above the horizontal line, line AOB is below the horizontal line. So the angle is alpha in the above the horizontal line and the angle is beta in below the horizontal line. If both the lines above the horizontal line, so alpha is the angle between line OB and OA. To measure the vertical angle of an object A at a station O, set up the theodolite at station point O and level it accurately with reference to the altitude bubble. Set the 0 vertical vernier exactly to the 0 of the vertical clamp and tangent screw. Thank you.